Hi, this is another lesson on implicit derivatives. For the first question, we're going to find the derivative of y for the equation x times y plus sine xy equals 1. And for the second question, we're going to find the equation of the tangent line at points or coordinates 1, 3 for x to the power 3 times y plus y to the power 3 times x equals 30. So we'll start with the simple one. So just finding the derivative of the first term is we're going to use the chain rule. So first function times the derivative of the second function plus the second function times the derivative of the first function. Now for the second term, the derivative of sine is cosine. And then we're going to find the derivative of xy. So same thing. First term times the derivative of the second term plus the second term times the derivative of the first term. I use a lot of brackets here. And then the derivative of a constant is just 0. So I'm going to simplify my work. And I'm going to expand all of this because I want to segregate this y here from the rest of the terms. Okay, now I'm going to move everything to the right side that doesn't have the derivative of y and keep the derivative of y on the left side. And now we're going to factor out a bunch of stuff. So first factoring the first derivative of y, and then you'll notice that x is shown in both terms too, so we can factor that out. And in this one, you'll see a negative and a y, so we'll factor that out. And now we can isolate this y here. Okay, so now we're left with this equaling negative y1 plus cos xy over x1 plus cos xy. So we could cancel these two 1 plus cos xy's, and you're left with negative y over x. So that's the answer for that one. Now we're going to move on to the one that's a little bit more trickier, finding the equation of a tangent line. So first I'm going to write out what the equation of a tangent line is. So this is the form that you're probably using. There's other ones like y minus y1, which is the same as f of x1, equals the slope. So the slope is the derivative of the function, so that's why I wrote it out as f prime x1 and then x minus x1. So I don't know if you remember from high school, y equals mx plus b. It's pretty much the same thing. I'm sure your teachers told you there's a million ways of finding the equation of a line. Okay, so we're going to start by finding the derivative of this equation here. So taking the first term, multiplying it by the derivative of the second term, plus the second term multiplied by the derivative of the first term. And now we're taking the first term for this one, multiplying it by the derivative of the second term, plus the second term multiplying it by the derivative of the first term is going to equal the derivative of 30, which is 0. So again, we're isolating the y prime here. And moving everything else to the other side. Now you're going to factor out that y prime. And then isolate. Okay, so now you're left with y prime equals negative 3x squared y minus y, minus y cubed over x cubed plus 3xy squared. Okay, so again, we're finding the points 1, 3. So we're going to plug those ones in. Okay, so 3 times 1 to the power of 2, so it's just going to be 3. Oops. Times 3, so 9. Minus 3 to the power of 3, which is 27. And then we have 1 to the power of 3, which is 1. Plus 3 times 3 to the power of 2, so 3 times 9, which is 27. I don't know why I wrote 22 there. Sorry. So that's going to be negative 27 minus 9, negative 36. 1 plus 27 is 28. So negative 9 over 7. So the derivative is your slope. So negative 9 over 7 is your slope. So we're going to plug it into that equation that I showed you up here. And plug our x1s into the equation as well. So we get y minus f of x1, which was 3, equals your slope, negative 9 over 7, times x minus 1. And that's the equation of the tangent line. Alright, I hope that helped. Thanks for watching, guys, and see you soon. Bye.